Okay, so let's get right into where we left off in our previous class. So the previous class was investment appraisal, which was question 1, March, July 2020. So let's do a quick the video has been uploaded, so you might want to quickly watch that, but let's do a quick high level review of what we considered. So right here is the question. Yeah. So where's that? Okay. Yeah, so right here is the question. So basically we had the company with 2 proposals really from 2 divisions. So we'd have the first division, which is division A, and then we have the second division, which is division B. So the key consideration in this question is that they were looking at purchasing a machine for production, and they considered 2 models. So whether they should purchase a smaller machine that has 80 million capacity, or whether they should purchase the bigger machine, which has 120, sorry, which costs 120 million rather, and has 20,000 units capacity per annum. And we did have in the question what the expected demand would be from the use of those machines. So the demand could be either we find ourselves having state A or we find ourselves having state B. And they gave us the probability of each of those volumes actually occurring or happening. So we looked at that part. We quickly solved the A part, which was to assess which of the 2 models of the machine should be purchased. And we agreed that based on available information, what was the answer again? Quickly, okay. It was about a recommendation. Yeah, so based on available information, machine A should be purchased because it had the higher return. So all we need to do was to find out what the expected quantity would be for each of those machine based on state A and state B, and we looked at the higher one. So the big question was where we left off, and the big question was, assuming the company has perfect information that would help it reach a decision, better decision, how much would the company be willing to pay for that perfect information? Our A question was, we don't have perfect information. We're only looking at available information, ignoring market research, and we got 42 something as the value. So what if the company had perfect information? Now, the truth is, if you have perfect information, you would always go for what is best. However, for you to know what is best, you have to look at all the available options and the net benefit that comes from all of those available options. So one of the things we quickly did in that class when we looked at the B part was to look at what are all the available possible options. So there are 2 machines. There's a small machine and there's a big machine. And you might have state A or state B. So what are all of the possible options? So you might have a small machine with a state A level of demand happening, or you might have a small machine with a state B level of demand. You might also have the bigger machine, which costs 120 million with state A. You could also have the bigger machine with state B happening. So those are all the possible outcomes. So based on that, we then computed what the net benefit would be from the possible outcome. So we stopped here. I just did the subtraction just before this class. So this is the net benefit when we subtract the net inflow from the investment. So therein, we have our net benefit. But let me pause a little bit. Maybe someone that wasn't in class watched the video and has a question when they watched the video, or maybe you guys, those are in class, looked at it again and said, can you just clarify how you got this figure or something? If you have, please, it's an opportunity for you to ask. If you have. If you haven't, I would encourage that you have a look at the video. That's the reason why I'm having it done on YouTube, really, so that it can always be there. I won't be battling with the link is expired and all of that. Okay. Okay, so I want to believe we're good, but if, or maybe you want to take time to look at the video before asking question. Okay, so let's get right into where we stopped, and then we'll move on to our focus for today, which is mergers and acquisition. So for those that are new and are just joining us, just follow along as we complete this. And then when we move on to mergers and acquisition, we're starting a completely new question. So for that one, you'll be able to follow along smoothly from the very start. And then for this, you can go back to the video and then catch up. Okay. So let's summarize what we've done based on our computation. And let's see what the results are telling us based on the computation we completed in our previous class. So let's look at what the figures are telling us. So basically, we have two machines. So we call them the small one, which is the one that is 80K. And I'm going to call the big one, which is the one that costs 120 million. So this one costs 80 million. This one costs 120 million. Whichever machine you have, you might have state A level of demand, or we might have a state B level of demand. So let's see what the results are from what we did from last week. So machine A, which is option 1, state A, which is what we call option 1. Our option 1 is our state A. Our option 2 is machine A, small machine state B. So this is big machine state A, this is big machine state B. So let's pick what the figures are and then look at which of them makes most sense. So our machine A state A is this one. So that is 3616. That is 3616. Our machine A state B, which is this one, which is a small machine, is 54080. Let's go to the big machine, which are the last two. The big machine state A is this one. The big machine state B is this one. Okay, so let's look at what would be our decision based on this. And then we can then find an overall value. So under state A, between the small machine of 80 million and the big machine of 120 million, which of them gives us the better return? Clearly, under this, clearly it is this one, so that is the higher value. So our decision would be to go for the machine that has a small, the 80 million machine. That's our choice. Now, under state B, we have to consider the two between the small machine and the big machine. Sorry, somebody want to speak with me? Okay, no. Okay, so between the small machine and the big machine, which of them makes most sense to us? We can clearly see that this is 54 million and this is 767. So between these two under state B, the big machine that costs 120.
So that means even before now,
Makes more sense.
We have somebody else. So
okay, please, I need to mute. Please mute yourself if you're not speaking to us yet. But if you want to speak, you can always unmute. But if you're not speaking to us, please mute yourself. Okay. So under the first one, the state A, the big machine has better value. Under the state B, the bigger machine, or which is 120 million, has better value. So let's now find the overall expected value based on our calculation. So our overall expected value based on the research, assuming we take in the research valuation. Okay, so what would be our overall value? So under state A, we're looking at the small machine. Now, the question tells us, when we read it previously, that both state A and state B, what's the probability of occurrence of each of those states? Can we still remember that? What's the probability that state A will happen? And what is the probability that state B will happen? It says that right here, it is estimated that two states of machine are equally likely. So they're equally likely, meaning that they have both 50% chance of occurrence. So they both have 50% chance of occurrence. So what does that give us as the total value based on the research information? So both have 50% chance of occurrence. Okay. Okay, so that would be under state A, we're looking at the small one, which is 3616. So 3616. It has a 50% chance of occurrence, which is 0.5. Plus, under the state B, our choice is this. That's our choice under state B, and this is our choice under state A because it's the bigger return out of the two. So that would be 67,712. 67,712. And state B also has a 50% chance of occurrence. Okay, so what is our overall expected return based on that? So I could just add the two up and multiply it by 0.5. It gives me the same thing. I can add the two up. Since are equal, so it should be 36,616 plus 67,712 by 2. So I have 49,164. 49,164. Now, this 49,164 that we just calculated now is the expected return on that project if the company has perfect information from the research. So how much can we pay? All we need to do is to compare this value with what would be our return without that research, which is the part A. So without the research, which of the part A that didn't consider all of the possible information, we agreed or we decided that the best would be machine A at 42,348. That was our decision. But with the perfect information, we're looking at a value of 49,164. So how much can you pay for that information? Let's see what the difference is, because if I'm going to pay for any information, it should not be more than the extra benefit that we get from that details. So without perfect information, we calculated it before, and we had a value of 42,348. So 42,348. 42,348. Okay, what's the difference? So I have 6,816. So this is the increase. So without that research, the value we expect is 49,164. With the research, the value we expect is 42,348, meaning there's a difference of 6,816. So if for any reason we want to pay for that research so that we can increase our return to this, from this to this, the amount that we should pay should not be more than 6,816. The amount to be paid for the research should not exceed the expected benefit. of 6816. Okay, so that would be our solution to that, because we're able to compare what the benefit would be with research versus what the benefit would be without research, and then we can make that decision. If you have any question, you can ask. That's why we're here. Let's talk. Let's chat. Okay. All right. Let's quickly look at the last calculation part of that question. I would leave you guys to have a feel of the theoretical part of the question. And again, maybe one of our classes we might just focus on just theory. But for now, let's do a little bit of the calculation, which is where students would have more challenges. Okay. So that leaves us, we've done our C part. Let's look at the D1 quickly, which moves us to division B. So if you miss the first part, this is an entirely new question, which is the division B part of the question. So entirely different appraisal. So you can follow along with this from the very beginning to the end. So he said for division B, which you've not touched on before, provide an appraisal of the proposal from the two suppliers and recommend the more appropriate proposal. So let's look at what the proposals are from the two suppliers, and then we can then see which of the two proposals would make more sense. So we don't have to read the question all over, just go to where division B is. So let's look at what division B is. It's all about what the proposals are in under division B. It says the division, I'm reading from here, which is the division B part. It says the division runs staff canteens for a number of major corporate organizations in Abuja. The meals are prepared at a central location. The division is in the process of purchasing a new industrial dishwasher. So that's the decision. They're looking at the new industrial dishwasher. Division has received quotes from two suppliers, Yarrow and Tony. Both quotes meet the necessary requirements. Yarrow is offering a dishwasher that will cost 9 million and has an expected life of 10 years, after which it is expected to have a zero scrap value. A warranty is expected in the first year. So that's the first guy saying, I'll give you a dishwasher, you're going to spend 9 million, and it has a life of 10 years. In the 10th year, you scrap it, and you're going to get 200,000 from it. However, after that, after you make that first payment, continuing maintenance is available at 5,400 for a single payment to cover the remaining 9 years, or alternatively by an annual charge of 750 payable in advance of the year of cover. That's okay, in advance of the year of cover. So that's the first proposal. The guy is saying you're going to pay 9 million for the machine, and then the machine has a scrap of 400,000. However, you have two options on how to cater for the maintenance after you bought the machine. What are the two options? You can either pay 5,400 now, or you pay 750 over a period of 9 years. So those are the two options. Pay 5,400 now, or pay 750 over a period of 9 years after you bought the machine. So this is what Yarrow is proposing. So we're going to look at what that turns up to. The second guy, Tony, is saying, I'm going to offer you guys a dishwasher for 7,350. It will last for 5 years, after which it will have a scrap value of 1.1 million. Then the supplier offers maintenance services at the cost of 720,000 payable annually in advance, and the first year's maintenance is covered by the manufacturer's warranty. The cost of capital is 6%. Okay, so let's get right into it then. let's look at let's begin with the first guy. And the first guy is Yaro. So what's the net benefit of his proposal? And then we'll move on to Tony and look at the net benefit of Tony's proposal. So let's begin with Yaro quickly. So what is Yaro proposing? So we're going to break down the question. So we identify the key elements in that question. So this is question D. Okay, so let's begin with Yaro. Yaro is saying that you would pay 9 million now to purchase the machine. And then in the 10th year, you have a scrap, in other words, a resale value of 200,000. That's pretty straightforward. He's also saying that in terms of maintenance, you have two options. You can pay 5.4 million one off. Or we can do what? If we don't want to pay 5.4 million one off, what other thing is he proposing? He's proposing something else. Or, which is right here, we pay an annual charge of 750 for a period of 9 years. So that's the second proposal. So that's the second proposal. So 950 for a period of 9 years. Okay. Or we pay 750,000 for a period of 9 years. For a period of 9 years. Okay, so the first decision we want to make with regards to Yaro, before we even compare Yaro to Tony, the first decision we have to make is on the maintenance. Do we pay the 5 million for maintenance one off, or do we pay 750,000 every year for 9 years? So that is the first decision we have to make before we even calculate what the benefit is for Yaro. So which of them? Now, I mentioned something where we did our computation on investment appraisal. I said that whenever you have a fixed cash flow for a period of years, we extend that cash flow over the period of years using the concept of what? Who would want to remind us? Let me hear someone's voice. Whenever you have a fixed cash flow for a period of years, we extend that cash flow over the entire tenor using the concept of what? Who want to remind us? We did it in a previous class. Thank you very much. Thank you very much. Thank you. That's great. So using the concept of annuity factor. Thank you. You guys got that. So please don't forget that. We extend it using the concept of annuity factor. So let's look at what the annuity factor is for 9 years so that we can extend it 750 over 9 years. We then compare it with a one-off payment of 5.4, and then we see which of them makes most sense for Yaro. So let's quickly calculate what the annuity factor would be. Don't forget the formula for annuity factor. Sorry. Okay, so the formula for annuity factor again, don't forget, it is 1 minus 1 plus whatever the rate of return is or the interest rate. The cost of capital is minus n divided by r, which is the rate of return. So that would be 1 minus 1 plus. So let's look at what the cost of capital is or the interest rate in the question. So we then use that to extend that fixed cash flow. Okay, so we're going to find that in our question. All right. Okay, so this is all about division B. And then right here, it mentions that division B's cost of capital is 6%. So that's our rate of return or cost of capital. So that's 6%. So 6% will be 0.06. So let's just plug it in there and get our annuity factor quickly. Okay, so 1 plus 0.06 raised to power of is for 9 years. So minus 9 all over 0.09. Okay, so what do we have? So that's 1.06, which is
sorry, sir. That should be 0.06. 0.06.
Yeah, 0.06. Maybe my handwriting is not clear, so let me write it clearer.
All over 0.06.
Oh, yeah. So where did I get 0.09 from? Thank you. Where did I get 0.09 from? Okay, maybe I was looking at the minus 9 on top. Okay, so that would be 1.06. What's my calculator? Okay, so let's solve that out. So that would be 1.06 raised to power of minus 9. Whatever I have, minus 1. I'm going to ignore the minus sign in my final answer because I'm working it backward. Divided by 0.06. Okay, so that's about 6.8. 6.8. So let's extend it. So that would be 750 multiplied by 6.8, which is 5.1. Okay, so 5.1 for 9 years versus 5.4 to pay one time, which makes more sense. It makes more sense for us. Clearly, 5.1 is cheaper, right? Right? Yeah. So since 5.1 is cheaper, let's now find the net benefit for Yarrow then quickly. So let's get our computation for Yarrow then, because we've agreed that it's going to pay it 9 years. So we can call this the year. We can call this description. We can call this a discount factor. We can call this the present value. Okay, so let's look at Yarrow's proposal. The cost of the machine, which is at the beginning of the period, is 9 million. That's what we're going to pay in year 0. Our purchase or outlay is 9 million. So that's going to go out of our hands. So that's an outflow. Okay, sorry, let me add a table. Let me put the amount and then the discount factor after that. So this would be the amount. Let me extend the table a little bit. Okay. So this would be our discount factor based on our 6%, and this will become the present value. Okay. So we're going to spend 9 million to buy the machine. And then from year 1 to 9, we're going to have maintenance. And how much is the maintenance per year? 750,000 per year. The annuity factor, we already calculated the annuity factor at 6.8. And then in the final year, which is year 10, we're going to sell that machine at a scrap. At how much? We're going to scrap it for 200,000 in the final year. So we're going to dispose or we scrap it. Okay, so this is maintenance cost is going out of our hands for 200,000. Okay, so this is year 0. Anything in the power of 0 is 1. So this is clearly 9 million. This is, we already calculated this one before at 5.1. So we're just copying it in. So let's look at what the discount factor is for year 10, which is just 1 year. Okay, so what does that add up to? So that would be, don't forget our formula for discount factor. You can use one of two. You can use 1 divided by 1 plus r raised to power of n, or you can use 1 plus r raised to power of minus n. N is a year, so in this case it is 10. Okay, so my calculator, I have 0.56, just keeping it to just two decimal places, 0.56. Okay, so multiply 0.56. Okay, so this maintenance cost, so it's an outflow. 0.56 by 200,000, 112,000. So you have a total of 13,988,000. So this is a negative, which is the net cost. Of Yaro's proposal. Any question on our calculation on Yaro's proposal? You can make use of the hand raise feature, which is the reason why we are here really, so that we can all just run back if there is. Okay. So let's quickly take a look at the second guy, which is Tony. Okay, so what is Tony proposing? Let's look at what Tony is proposing. Okay, so let's look at what Tony is proposing. So we're in Tony now. Tony is offering the same dishwasher at 7,350 million. So Tony is saying, I'm going to give you at 7,350 million. This machine is only expected to last for 5 years. The other guy is only for 10 years. It's only expected to last for 5 years. So we need to factor that into consideration while comparing it at the end of the day. After which, it will have a scrap value of 1.1 million. So the cost is 7,350. It will be for 5 years, and then it will have a scrap value of 1.1. Now, what of the maintenance? The maintenance is at an annual cost of 750, payable annually in advance. The first year's maintenance is covered by the manufacturer's warranty. So out of 5 years, first year is covered by manufacturer's warranty. So we have 4 years left. We have 4 years left. Okay. Tony is not giving us option to pay everything upfront. It's only saying my own is 720 every year for 4 years. I'm giving you guys 1 year off, so you have everything for the remaining for 4 years. So let's see what Tony's proposal will add up to. What it amounts to. This is 5 years. So let's see what it amounts to at Tony's end. Okay, so look at Tony's end now. So we would use the same format like we did for this other guy. For Yaro, so we have the year, just using the same heading. We have the description. We have the amount. We have the discount factor. We have the present value quickly. Okay, so Yaro is saying the machine, based on my own proposal, will cost 7,350 million. Year 1 to 4 years, you do maintenance. I'm going to give you guys 1 year free. So you do maintenance for 4 years. So that's 1 to 4 years. And how much is the maintenance again? Oh, I missed that. What was the value again from the question? How much is Tony proposing that we pay? That is paid every year for the maintenance. Okay, so Tony is proposing an annual maintenance cost of 720,000. So we'll just note that quickly. Then the scrap value, the 50 is 1.1 million. Just take note of that. Okay, so the maintenance is 720. We're going to cough out of our pocket. And then in the final year, we're going to dispose of it for a scrap value of 1.1 million. Don't forget our discount factor. The cost of capital is 6%. So this is here 0. Anything raised to the power of 0 is 1. So we don't need to bother ourselves about that. So that is 7,350 out. This is 720 constant for 4 years. So we need to extend it using the concept of annuity factor. So let's calculate the annuity factor for 4 years then. The annuity factor for 4 years. Okay, so that is 1 minus, formula again, 1 plus r raised to the power of minus n divided by r. So that is 1 minus 1 plus the rate of return or cost of capital is 6%, so which is 0.06 raised to the power of, this is 4 years. So minus 4 divided by 0.06. Okay, so what do we have? It's my calculator. Okay, so that's 1.06 raised to the power of minus 4 minus 1 divided by 0.06 gives me 3.47 on average. So that's 3.47. Okay, so 3.47 multiplied by 720 by my calculator gives me 2,498,400. Okay, in the last year we just calculate the discount factor because it's just for 1 year. So that will be 1 divided by 1 plus r, which is 0.06 raised to the power of 5. Okay. Okay. So my calculator, that gives me 0.75. 0.75. Okay, so that's a total of 825,000. So what's our net cost? Yeah. So net cost here would be 7,350 minus 2,498,400, and then the inflow gives us 9,023,400. Any question on these two proposals up to this point? Any question? Okay, so let's compare. Don't forget that. Okay, someone want to say something? Because that's why we're here.
Yes, yes,
Okay.
sir. Good evening, sir. Once.
Yeah, good
Uh,
evening.
My question is that the proposal for one project is 5 years, the other one is 4 years.
Yeah, we're gonna come to that. Don't worry, we're gonna come to that. But I just wanted to be sure you get the calculation first. You can't compare 10 against 5, so we have to equalize it. We have to get a way to be able to equalize it so that they are both on the same benchmark. Is that okay?
Yes, but it's about the discounting factor, the annuity.
Okay. Okay, go ahead.
My question is,
Maybe I'm better.
why don't we compete for 10 years instead of 9 years? Since the warranty is for the first year.
So if you take off the first year, how many years do you have left?
9.
So that's what we're doing for 9 years.
Or
Okay.
4 out of 5.
Yeah, the same thing with the second one. The first year is a warranty out of the 5 years. So you take off that first year, we have 4 years left for Tony. And then for the other guy, if you take off out of the 10 years, the first year is warranty. It gives the guy free warranty on that first year. If you take off that first year, we have 9 years left. Is that clear?
Yes, sir.
We're saying that we've calculated the values for the two projects quickly. However, Yaro's proposal is for 10 years. Tony's proposal is for 5 years. We can't compare the total cost for a 10-year-old project with the cost for a 5-year-old project directly. However, what we can do might be for us to calculate, for example, look at the cost per year. Try and evaluate what the cost per year would be. So when we know what the cost per year would be for 20, we can then look at what the cost per year would be for Yarrow, and then we can compare like for like. So another option would be that, okay, we make 10 years equivalent of 5 years, 5 years equivalent of 10 years. So there are different options we can take. But I think I would prefer to do it year for year. So look at what's the equivalent for per year for Yarrow and what's the equivalent per year for Tony. And if you're going to do that, this is the formula you're going to use for that, for comparing projects that are of different lifespan. So it's the same thing you would do if, for example, you have an NPV question where one project is for, say, 10 years, another project is for, say, 7 years. You can't compare the two. You need to annualize the two. So what you can do in that situation is to find for each of the project, whatever the NPV or the net cost is. If it's cost, it's NPV. If it's a project that has a lot of inflow, whatever it is, you multiply it by the annuity factor. Not multiply, we're looking at per year, so we can multiply. So you divide whatever the cost is, you divide it by the annuity factor. For the entire tenure. That way, you can, whatever value you have here would be the annual equivalent. It will be the annual expected equivalent, because this annuity factor would take in, by the time you divide it by the annuity factor for that year, it gives you what it is per year. So let's do that quickly and see which of the two makes more sense. So we have Yarrow, we have Tony. So let's do that quickly. The net cost from our calculation, or the NPV net cost, whatever you want to call it, for Yarrow, it is 13,988. 13,988. For Tony, it is 9,023,400. 9,023,400. We need to divide it by the annuity factor for each of them. Don't forget that Yarrow, total tenure of Yarrow's project is 10 years. That's the total overall tenure. And the total overall tenure for Tony's project is 5 years. Okay, the rate is 6%. So that's what the annuity factor is for those years now. So for Yarrow, that would be 1 minus 1 plus the rate of return, which is 0.06 raised to the power of minus 10 divided by 0.06. For Tony, that it will be 1 minus bracket 1 plus 0.06 raised to the power of minus 5 divided by 0.06. Okay, so what do we have? So by my calculator, okay, so for Yarrow, by my calculator, I have 7.36. Okay, so what will be the annual value then? What will be the annual expected cost? So 13,988,000 for 10 years divided by the annuity factor of for that 10 years of 7.36. So annually, the equivalent annually, it's 1,900,543. Okay, so this is 7.36. Let's look at the second one, annuity factor for 5 years. So for my calculator, I have 4.21. So 9,023,400 divided by 4.21 gives us 2,143,325. Okay. So which of these proposal makes more sense? So let's just put a recommendation quickly so we can round up. So let me just make my point that we cannot compare directly. We cannot compare directly. 10 years, a machine that is going to last for 10 years versus 5 years project. So we have to compute the expected annual values. So based on the expected annual values, Yaro's proposal is cheaper. Yaro's proposal is cheaper and therefore recommended. Okay, any question? Don't worry, quick, we're done with time, so quickly, yeah, we're good. All right, so any question? So the key takeaway for me, for you guys from this question is, when you have an investment proposal where the project you are comparing are of different year span, please take note, you cannot compare directly a 10-year project with a 5-year project or a 6-year project with a 3-year project because they have different lifespan. So you need to look for a way to find the annual expected value. And how do you find it? Whatever the net cash flow is from each of those projects, you divide it by the annuity factor for the entire term of the project. And then you compare them, and that way you can find on an annualized basis which of them is a better project. Okay, so that's our question 1. So I hope you guys have, at least help you guys to strengthen your knowledge on how to approach question like this. I can repeat questions, so you never can say, if I just have a word-for-word repetition of one of these questions that we're practicing. All right. So let's move on to our next question, which is basically our focus for initial focus for today. So okay, so I just stopped the recording of that. So